Thanks, Colleen. Okay, hi again, everyone. Welcome to the OpenAQ Python training today. I'm very pleased to be, the one providing this to you. So thanks again for joining us. Before we start, I know some of you have attended Colleen's training last week, or a couple weeks ago, about our Platforms Explorer app. So I was curious since it's our first time meeting today, and this is a lot more technical. I kind of wanted to get to know you a little better, and see how comfortable you are with the tools that we're going to be using today in Python. So if you don't mind, maybe either put it in the chat or, open up your screen and let me know if you've never used or have no experience using Python before, or if you've used it for maybe under a year, or you're pretty proficient in using Python, used it over a year, that would be fantastic for me to like pace myself better and not go over very simple Python stuff, so we can get to, better OpenAQ Python things. Um, gonna just take a look quickly at the chat to see um, if that's possible. I actually don't know how to open up the chat at all. Do you see anything in the chat, Colleen?
So far, not yet.
Okay, I'm gonna give them maybe a minute or so before continuing on. Um, And I'm assuming that everyone is joining without the intention to follow along and have the code run on your own computer, which is fine. I'm gonna share my screen anyway, and we'll, go step by step through the tutorials, and feel free to stop me anytime, or, you know, um, let me know if I'm going too fast and we can slow down a little bit. Okay, perfect. They're here. And then welcome, Lily. Okay, I think we could probably keep going for now. Like I said, just stop me or let me know to slow down at any point in time if you think we're going too fast. So, the agenda of today would be I'll spend maybe 5 to 10 minutes going over the slides to cover some key concepts and general stuff about our Python package, and then we'll go ahead with the tutorials for the remaining 30 to 40 minutes of the training session, where we will go over common workflows, and using, the Python, OpenAQ Python SDK integrated with, data analysis and visualization tools within Python. And we do have maybe 5 to 10 minutes left where you can share questions. But again, stop me anytime during the session if you got any questions whatsoever. Thank you, Clement. Over to you. So we quite have a bit of like a variety in terms of skills right here. Just let me know anytime if I'm going too slow or too fast. So in general, our package, essentially what it is that it allows you to connect to our API and programmatically access air quality data that is hosted on the OpenAQ platform. Now you might be wondering why, because you know how to use Explorer, you can use the API from the command line using an URL. Why use the Python SDK, right? So as you recall from, your Explorer training session, you're able to download an CSV files of the data, but then it's very limited in terms of the number of data you can get, the range of time periods you can get the data from, and you have to click on single individual locations to get the data. So it's not exactly very efficient if you want, a big amount of air concentration data. The Python SDK then comes into play because it allows you to access those data in bulk from any location and anytime. It also employs very user-friendly helpers, for example, expressive error handling, where if you make a mistake, the system will let you know and point you to the right direction to correct it. Preemptive error catching, so if you make a mistake, again, you don't hit the database or the API so as to break our system. And automatic rate limiting, as in the system will automatically goes to sleep and waits until your rate limiting resets before it starts fetching data from the API again. It also has more intuitive data access in comparison with, command line URL. So it'll give you Python objects oriented tools to work with instead of API JSON string responses, which sometimes are pretty hard to parse. And it's all fully typed with autocomplete and inline documentation, so make the coding process for you to get the data a lot easier than other tools. For example, clicking on the screen and using curl. Then, and on the screen right now is the data models that we employ for OpenAQ. It looks a little intimidating, so you don't really have to understand every bit of it right now. Just know that all of the nodes, like locations, providers, countries, parameters, stand for resources that are available to you using the API, and all of the edges or the arrows connecting the nodes are the relationships, or it really does tell you how one resource is related to another. So it's a pretty large ecosystem of air concentration data. But today you can find the full definition of each resource on our documentation website. But for the tutorials today specifically, we're going to be going over three resources, and I would arguably say they are the most important ones. So I'll talk about them a little bit more. Locations, essentially, you can understand locations as, air monitoring stations. And at each air monitoring stations, you would have, sensor units that measure different types of pollutant or, parameters. For example, PM 2.5, PM10, NOx, SO2. So at each locations, you can have one or multiple sensors. And once you have access to sensors resource or have a sensor's ID, you can then access measurements data or air concentration readings from that sensors from any, period in time that you might be interested in. So that's kind of the hierarchy that we're going for today, talking about in the tutorials, going for locations first, looking for what sensors are available at that location, and looking for the measurements data at each of those sensors, or specifically PM 2.5 sensors that we're going to be looking at today. Um, and I'm just gonna go over some of the key concepts. These are really short, but if you've used Python before, I'm sure you know about some of this already. So API key works like a password for us to authenticate your request to the API and manage your access. Um, Rate limiting, everyone has a rate limits of 60 requests per minute, so and 2,000 requests per hour. So that what that means is whenever you send a request to the API, within a minute it will decrease from 60, and then when you run out of that 60, you have to wait for a minute for it, for you to be able to access and request data again from the API. This should meet most of your needs and use cases. But if you ever, like need an increase in rate limiting, feel free to reach out to us and we can discuss more about, increasing your rate limits for certain tasks. Pagination. So this is like, by default, whenever you make a request, the number of results that are returned to you would be by default 100 per page. But know that this is adjustable and can be set up to 1,000 results per page. And you will find that if you are to access measurements data, more often than not, it will be more than 1,000 results, in which case you can loop through the page. As you can see on this little bit of code here, this is page one, and you can loop through the pages until, found is zero, meaning no more data is found on that particular page. The tutorials. We got done with that quite quickly. I wanted to stop a little bit to make sure that everything is clear for now, and if anyone has any questions whatsoever. Do you have any questions, Colleen? There isn't a lot
So
for
we're not
now.
really, no.
Okay. All right. So I'm just gonna go ahead with the tutorial again. I'll put it in the chat or just stop me if you have any concerns or wanted to make clear of anything that I'm talking about. So the tutorial, as you will see, is going to be very exercises driven and we'll be working as a primer to our OpenAQ Python SDK. Like I said before, to Clement, having the code run on your machine as we go is encouraged, but entirely optional, so no pressure at all. And since I think pretty much all of you is gonna just follow along, I'm just gonna, go over to the tutorial slide right now. And if you have any difficulty accessing the code after the training session, let us know and then we can make it work. We'll be sending all of the materials to you, and we want to make sure everything works fine. And I want to make sure you are seeing my screen right now.
Yep.
Perfect. And then, okay, so the tutorials, I updated this yesterday, but basically, like I said, we're gonna be going over the common workflows, and by the end of this tutorial, I hope you would be able to get a couple goals accomplished. The first one obviously would be setting up your OpenAQ client in Python and know how to access the API programmatically with our SDK. We will also check out the documentation a little bit so that you know how to like write your code and then have kind of some kind of a guide for you to work with the resources at the same time. We'll go over location, sensors, and measurements resources with the end goal of, getting all of the data. And the example would be, getting all air concentration data in Ghana. I hope you'll be able to see how we integrate the Python SDK in your data analysis and visualization pipeline. And last but not least, to utilize the API to solve problems for your air quality needs. And as you can see on the left-hand side here, I got the outline for today's tutorials. We'll go over 6 different topics, and then in each topic, there will be, you know, um, questions that I kind of outline for you to try and answer with the Python SDK. And each of the topics is going to be, built on top of each other. So the building blocks so that by the end of topic 6, you'll, be able to build a visualization about the data, measurements data in a particular location, which might be helpful in, a dashboard context or even a data science context where you want to be presenting this kind of information and highlight it to, say, your manager, for example. Um, okay, and since you're just following along, this is not super important right now. But if you're, doing it by yourself after the session, please do note that you have the latest version of our Python SDK install. And you can see that if you're using MoLab on the left-hand side here, OpenAQ version 1.0.0, RC2, if you use, like a notebook or like, like a terminal, you can also check out with your version packages manager, pip list to check out and make sure that you got the right version of Python installed. And the way you use this tutorial, I would highly recommend going over each cell and run them one by one, but what you can also do is run all of them at the same time and go through them as you go from top to bottom. And we're gonna get started. The first cell is really simple. I'm just gonna import the packages that we're gonna be using for today. You don't really have to care about most of them, but the most important would be pandas right here. And I'm sure if you've used Python before, you're pretty familiar with the package. It's data manipulation tool within Python. And then we got Altair, which some of you might not know about since it's rather new, but it's basically a data visualization tool. Again, it's not necessary to know these packages as long as you know what they do in order to understand what we're going to be going through with, the data today, because we wanted to learn about the Python SDK. So the first step to every single workflow using our Python SDK is always to configure the client so that you're able to open up a connection with the database or making a request to the API to fetch data from the database. This is where your API key kind of comes into play because like I went over before, it kind of acts like a password of sort where you're able to be connected to the database. And please, I think you've gone over this before. With creating an account, you'll be able to access it from Explorer and going to your profile setting. Please do not share your password or API key with anyone, but I'm just gonna give you a glimpse of what my password is and then enter right here. And then if it's, like a tick mark, it means that it works. And then I'm going to run this very quickly to do a simple validation check. And if you receive something like your OpenAQ API key has been successfully saved, then it means that you're safe to proceed with with the rest of the tutorial, which we will proceed with right now. And this usually, if you're working independently on a private notebook, I would just replace this bit that I highlighted right here, API key variable, with the string of your API key. But this is because we're sharing this publicly. I wanted to keep it, all set up in an environment so that people don't get to see and copy and paste or open AQ API key and steal it. And then now that we have set it up, it successfully sets up right here, the configuration. We'll run an example request to the API to make sure that it works. And you can see a location response comes back when I make this call. We'll go over this a little bit, but this essentially means that the client is the name of my connection to the database, which we have set up with our API key right here. And then down here, we're calling the locations resource. And then we get um, the locations data for a location with an ID of 42. And then because of that, because we're calling the locations resource, what we're getting back is the location response. And that is actually, the explicit way of opening up a connection with the database. Now, there is another way of opening up a connection, but that way doesn't work in a notebook or, a Python REPL context. So I'm just gonna leave, context managers here for you to review in your own time. And what context managers do and differ from what we're doing right now is it automatically close the connection for you after, for example, running a Python program. Um, if you're explicitly opening the connection like we're doing right now, just remember at the end of your notebook session to do client.close so that, nothing is leaky whenever you open up a connection with the SDK. And I got this right here at the very bottom, client close, that I'm gonna have to run when we've finished this training session. Okay, so let's go over the structure of the response for a little bit, because we saw that earlier. And so the structure of response is going to be the same for responses types, meaning if you call a locations resource, you call a sensor resource or measurements resource, everything is going to be of the same structure. And it typically includes three parts that are accessible by dot notation, meaning you can do dot and then the name of the part, and then you'll be able to access that information from the response. So right here, what I have, I just run it again and then assign it to a variable for a sample location. Um, the way I would read it is like I'm using the get method on a locations resource. So going backwards and then go in what's within the parameter for locations ID 42. And after I run it, this is what I get for locations response, just like what we did earlier. So the first part, headers, is going to be where you access information about your rate limit uses. Meta would be metadata or information about the results that you're getting. For this one, page means page number one, limit by default 100, like we covered earlier, and found one, meaning in the results set, there is only one location that is found. And as you can see here, results, location object, and that's the only location object because we're calling the get method, meaning get one location from the locations resource right there. And I'm gonna illustrate how you would do dot notation. For example, I want to get information from meta. I would just do dot meta, and then I want to see how many results I got from meta. I would just do dot found, and then right here I got one. So that's how you use the dot notation with the responses whenever you make a call to the API. And that takes us to the second topic of the tutorials today, which is to look at the locations resource and ask for, requests for information about the locations in the area of interest. Um, Depending on your needs, you will see that there are three different ways you can do this with the OpenAQ API or the Python SDK. First would be using filtering by using filtering with arguments. Second, by using bounding box. And third would be using coordinates and radius. And so for this topic, I have a couple questions that I think would be pretty good to answer with using the Python SDK. The first one would be how many locations in Ghana do we have on OpenAQ? Second question, how many PM 2.5 monitoring locations in Ghana do we have on OpenAQ? And the last but not least, how many locations in Accra, so not country level anymore, just city level, do we have on OpenAQ? So filtering for locations. In the earlier example that we just talked about with locations 42, as you can see, we've accessed the locations resource again with a get method. Now, in order to answer question one, which is about, how many locations, so that's more than one, we want to get not one location, like with the get method, but we want to get multiple locations. And so in order to do that, what we can do is we access the locations resource again, because that's what we want to look at. But now we're using the list method. So get method, one location, list method, multiple location. Now let's go to the Python documentation page and learn a little bit more about the list method. So when I was on the landing page, I would just click get started and on the outline on the left-hand side. Um, these are all of the stuff that we have in the documentation, but since I'm working with resources, I'm just going to scroll over to resource right here, and I'm interested in learning more on how to work with locations. I'm just going to click on locations right here. And you can see, like the description, full description of what a location is right there. What are the available methods? We went over get quickly, but now we wanted to look at the list method. So you can scroll all the way down, but if you want some help with navigating, you can just on the right-hand side, click on the outline of list multiple locations. And these would be, all of the arguments or all of the filtering in a way that you can work with for the list method. And sometimes these might be difficult to understand. So we do have, a table that tells you what each argument means and what the input requirements for each of them is. Because the question is now we want to get all of the locations in Ghana, I would be looking for an argument that pertains to country sorting. So I see right here, this is a country's ID that I can work with if I want to filter by country, or ISO alpha 2 code for the country or territory of the location would be something that I can work with as well. So we identify that these two are what we need. We go back to the tutorials. We also have this um, page that allows you to browse for alpha 2 codes right here, and also the ID. And these are, uniquely identified numbers associated with each country within the OpenAQ database. So I'm just gonna look for Ghana, and I know that the ID for Ghana is 152 and ISO is GH. Go back to the tutorials. And one thing to note right here is that ISO must not be accompanied by country's ID, and country's ID in the same vein cannot be accompanied by ISO. So you can just choose one, and it'll both be the same results, whether you get it with, an ISO argument or country's ID argument. So it's either DH or it's country's ID 152. And I run it and I get a locations response here. And we can now look further to see what this locations response gives us. I have assigned the results to, a Ghana locations variable. So we're gonna look at the Ghana locations variable response now. And as you can see in the meta, 60 locations are found. So we got the answer to the first question, that being we have 60 locations or air monitoring stations in Ghana that are on OpenAQ right here. 60-year monitoring by accessing the found within Meta using dot notation. And for question number two, how many locations that are, monitoring PM 2.5 do we have in Ghana? As you can see right here, I'm just going to scroll up and take a look at the Ghana locations again. Okay, let's take a look at the first response, meaning the data for the first location. We got an ID, got the name of that air monitoring station, we got country, but if you look all the way down at the sensors attribute, remember sensors is, what's right underneath locations. We got two sensors right here. So this means that this location are monitoring first PM10 and second PM 2.5. So if you are to do, a for loop for each one of the result within this results list, you will be able to count how many of each parameters, how many locations that each parameters are, being monitored in Ghana, which is precisely what I'm doing here. I just loop through the sensors attribute of each of the location within Ghana locations results. And then if I find a parameter that's already in a dictionary that is new, then it will be assigned with one. Otherwise, I'm just going to plus one to that number that if it's already found. And I run that, and you can see this is a very high level overview of what the state of air monitoring is like in Ghana that are available on OpenAQ. And as you can see, PM 2.5 is the most common metric here because we have 60 locations, and we also have all of those 60 locations having data on PM 2.5. Now it's just a little quiz, but feel free to treat it as a homework of sort when you go over this after the session. Okay, so now that we've gone over how to use filtering to answer questions about looking for a location, another way of, looking for a location would be making geospatial queries. Um, these are especially useful for geographic queries of, say, subnational level, meaning you're not looking for, Ghana or Pakistan or Vietnam, for example, but you want to do, like a city basis kind of search. So that's what we're going to do in question three of topic two, which is to find locations that are available in Accra right? And there are methods within the list method to do that. So I'm going to quickly go over to the documentation list again. And as you can see right here, we got radius, we got coordinates, and we got VBox. Radius and coordinates go together, and VBox is just a standalone argument that you can use to kind of look for um, air monitoring stations. So this is a tool that I often use to get, the VBox of locations of interest. So I'm just gonna drop it in the link here, zooming over Ghana, and then let's look for Accra right here, right here. And what I do for a bounding box is I'm just gonna, draw a box around Ghana. And then after I draw roughly like a rectangle, I would be able to see here the box coordinates, right? And so the coordinate, remember it has to be in EPSG 4326 and WGS 84 in order for it to work. So this right here, but not this on the right-hand side. Coordinate format is important too, because we see here, this has to be in the format of, XY, XY. So longitude and then latitude. So you want it to be like this up here instead of lat long down here. So if you are to copy and paste this bit of the bounding box, come back here and then just do it. And then here I'm just, extracting the found within meta to see how many locations that I find within that bounding box. It would be 11 locations are found within that bounding box. Maybe it's too small of a box that I was doing around Accra, but just leave it there for now and move on to the next method, which is to use coordinates and radius going together. Here it's a little tricky because it's instead of long lat, it's lat long, but as long as you make sure that you got it right, it should be relatively simple. So I'm just gonna do, like the center here, and I need to switch the format to lat long, and I'm just gonna copy and paste the center of that rectangle right here. That is lat long right there. And I'm picking a radius of 10 kilometers. Radius has to be in meters. So 10,000 is 10 kilometers. I'm gonna run it. And then they find, 21 locations with this method. Probably because I'm choosing a bigger radius than I would do using a bounding box like I did above. So that's how, you look for locations, either by filtering purely with, arguments that we can find up here, or you do a geospatial query. So pretty simple and pretty straightforward. Is there any questions at this point that I can answer? If not, I would just move forward with topic 3. Again, feel free to put in the chat or raise your hand if you need any further clarification. Okay, so if you still recall from the data model that we went over before, after we got locations, now we got to, getting the sensors IDs from those locations in order to get to the measurements data at those sensors ID. We went over this before, that being each location had one or more sensoring units called sensors. So I'm not gonna do that again, but it's important to note that, not to confuse air sensors with the sensors resource, because air sensors is essentially a location type. We have two location type, the first one being air sensors, the second one being reference grade sensors. But these air sensors are just, referring to the units at each location that measure different pollutant or meteorological parameters. So, what do we do if we want to get sensors from these locations? We can refer back very quickly to the locations resource. Look at the methods right here, and there's the sensors method for accessing a list of available sensors at the location for a given location ID. which is precisely what we're going to be proceeding with um, in this one. So quiz, very straightforward here. You can treat it as, like a homework of sort. And I'm just gonna go ahead and do this one because there's an important distinction that I want you to be able to make whenever, using different methods of the same resource. So the question is from location. So I'm going to make a call to the client. I'm going to access the locations resource. I'm going to do sensors methods. And then within the bracket, as you can see right here, this is autocomplete that you can use for, ease of coding. And I want to do this location ID right there. So I'm just gonna copy and paste it right here and then run this. So this is the sensors response when I ask the API to give me the sensors at location like this. That's the location's ID. And the result is a sensor object. And you can see right here, this one is a sensor that monitors PM 2.5. And this is the ID that we will need to access the measurements associated with this sensor. And as you can see, this is a sensor object that we get, right? But then, so if you still remember earlier when we were looking at Ghana locations, right? Each of these location objects also contain information about the sensors themselves, which we already accessed using a for loop before. But these are sensor-based objects instead of sensor. And if you call the sensor method, you got the full sensor object. And as you might already notice, this is a lot more information than sensor base. Within sensor base, what you can get access to is just the ID, the name, and also the parameters that's being measured there. Whereas for the full sensor object, you get information like coverage, when's the first time you got data on this sensor, when's the last time you get data on this sensor, what's the latest time that you have any data on this sensor at all, and a attribute for summary statistics for data at this sensor. So if you want to, see the full thing, accessing from the sensor's method would be way better than seeing it from, locations, as we see right here, right? It's super long if you are to access it from the sensors method. And with that, we're moving on to measurements data because now we know how to access the sensor's ID from locations. So we'll move forward with accessing measurements data, if you still remember the tree from before, from sensor's ID. And you will see that there are two ways of accessing um, the measurements data on OpenAQ using the Python SDK. The first would be getting the latest measurements at a location, and the second way would be getting measurements data by the sensor ID that we just looked at. And so if you want to get, the latest information at a particular location, what you do is you just call the latest method, and then within the bracket, that would be the location ID, and call the locations resource. And that what you will get is the latest response that will tell you what are the latest data that I can get from this location. And then for this one, it looks like location is measuring two different types of pollutant. Right here, if you want to know what pollutant it is, you'll have to look at, the sensor's ID in order to know. But if you call latest, you would just know that this is the average value for this location at this coordinate. This is the date time where that value is recorded. The location ID is such, and the sensor's ID is such. So you have enough information to poke around and kind of like find where these latest information is and also what latest information it is for. Maybe something to play around with after the session when you have the notebook for yourself. But as you can see, that this method only gives you data from a single point in time, that being the latest. So this one hasn't been updated for a while. This is from February of 2024. So then, however, if you are to use the list method of the measurements resource, which we're, concerned about right now, you can access measurements data of various base calculation for any given period. So this is a lot more versatile than accessing the latest method at each location, right? So this request below right here that I'm making is gonna be giving you, so let's go over the arguments for a little bit. So here I am accessing the measurements resource and then dot the list method of the measurements resource. And then within the brackets, it's not going to be a single, ID anymore because, and this is important to note too, whenever you make a call to the measurements resource, it is best that you put constraints in your request to the API because a lot of the time it's going to be, the data that's going to come back to you is huge. So putting constraints means that you'll have, less waiting time and also get only the data that you need. And at the same time, ensure that you don't, break your, rates with a lot of requests that you're not going to need the data for anyway. And some examples of what those constraints are would be right here. So sensors ID are required, is a required argument. Data is also a required argument. So measurements for data here means that you want the raw measurements for the sensor's ID of such number. And then date time from is, one constraint. I want measurements, raw measurements data from this sensor ID from, a date time object of 25th of December to 31st of December of 2025. And that's just, a week, the last week of December 2025. And already you're getting a huge amount of data. And this is not even the whole thing because it's truncated, so it's shortened to only 5,000 lines. The reason why there's so much data for this one is because you got data for every 5 minutes. So it's a lot. And most oftentimes, you will see that 5 minute frequencies are pretty unnecessary for many analysis tasks. Which takes us to the next session about, evaluating summary statistics, where we don't need to look at every single and get every single raw measurements data out there. We just need to look at, summary statistics to identify outliers or, poorly performing locations in our data set for these sensors. Or in other words, let's answer these questions. Using days data for all of 2025. Where are the outliers in unstably performing locations for PM2.5 in Ghana? And then sick one, visualize the median, min-max, interquartile range and coverage for 3 locations for PM2.5 in Ghana. So the first step to question one would be, okay, now I want to get measurements data. In order to get to the measurements data, I need sensors ID. I already got the locations, so now I'm going to be, looping through Ghana location results to get all of the sensors ID that I would need for this task. It has to be a sensors ID for parameter number 2, which is, PM2.5. So I'm just going to run that quickly again. We should be expecting, 60 PM 2.5 sensors because we saw 60 PM 2.5 sensors before for our Q2 results, which is what we get when because all of the results of the sensors ID, I put it in a dictionary right there, and the length of that dictionary would be the number of PM 2.5 sensors in Ghana that I got. And then next up, this could be, a little bit intimidating to look at for now, but rest assured that it's mostly renaming the columns so that they are easier to work with. But essentially, what I'm doing in this cell right here is the most important bit is this is me looping through the items in the dictionary of Ghana PM 2.5 sensors. And for each of the item, I am making a call to the API to please, with that sensor's ID, give me the day's data, so daily data, if you will, from the date of January 1st of 2025 to December 31st of 2025. So days data for sensors ID for the entire year of 2025. And the rest of it is just me putting everything in um, a pandas data frame, and after that, renaming the columns. So I'm just going to run that real quick. It's going to take a second for it to load, but this is already preloaded from before. But as you can see, this is the table of summary stats that we're looking at. And you might already be, aware of all of these minus 999, which is that data that we'll need to filter out after this exercise. Um, and we got, okay, so now that has finished running. I'm just going to run it again to make sure it works right here. So we got, oh, sorry, right here. So 8,600 rows of summary statistics only of data. But because days data, where data is not available, will not be returned by the API, what I'm going to do is to create a grid of every single day in 2025 and then cross-join it with the pairs of location ID and PM2.5 sensors and fill out the dates without any data with NA. And from 8,000-ish rows, we get to almost 13,000 rows right here with NA for empty. And so I'm just going to rerun it to make sure this one works. This is the box plot that shows you for every locations in Ghana with any data at all, what the summary statistic for the median looks like for the entire year of 2025. And you can see these kind of stick out like a sore thumb almost with massive outliers. I mean, this one is really bad because there's a lot of 999 if you hover over it right here. So this one is a lot better, but it does have a max of over 1,500. And it still might be good if we are to remove it, and if that max value is just one day. But for this exercise, I'm just going to drop those two locations, and then redo the box plot to kind of, see what it looks like for all the locations, which is pretty decent, I would say. And I've designed it so that when you hover, it's like the number of days where there are data for each of the locations. The box gets a lot thinner here, probably because we don't get, as much data for those nodes. Whereas here it's like the whole year or a little bit less than the whole year, 275 days. Interpretations, you can perhaps work on that on your own. So what I'm doing down here is I'm just going to answer the second question, which is, visualize the median, essentially visualizing this table of data that we have from here to kind of see where the medians are for every day, where the interquartiles are, what is the area chart for min-max, and I also, add, a coverage chart to that visualization just for us to kind of see more nuance of the data. So that is just a function that's going to draw a chart for you. And this is calling that function with the location ID of interest. And this is, what we are able to produce with, just that one call to the API asking for measurements data. We already have, like this thing right here that covers with the line being the median, and all of the light blue would be interquartiles, and the lightest blue would be the min and the max. And it's a lot higher. I can see it from December through February-ish year. So something seasonal, I guess, might be happening there, depending on the time of the year, which we can kind of see a similar pattern in this one. This one is a little problematic for some reason. It's zero median, for the entirety of the 3 months here. So it would investigate more and also daily coverage. Still pretty good, so I'm not sure. We might need to look at this more. But red essentially means coverage is under 75%, and blue means 75 and above. And this one, this just means that there's no data before November. And we just have a little bit of data for this one. So I'm just gonna speed up a little bit because I know we're quickly running out of time. So sensor coverage, we went over it a little bit here. Uh, Sort of a hint to how coverage might be important in aggregation. So one ways of using average would be, like seeing filtering, because a lot of the time we only care about, days with over 75 coverage. There's no point of grabbing a day's data if you only have maybe 2 or 3 data points for that day, right? Does this section essentially asks you to like compute the annual average for PM 2.5 concentration at each location, and then do that again, but filtering out all of those days that are under 75% coverage. And like before, I'm getting the measurements from the measurements resource by using the list method. I'm getting days data. Oh, this is an example, right? This is just an example if you are to like check out the measurement. I think we've already seen this from before. The results would be, for this measurements would be coverage right here. Expected count because, you're doing data days. So an important thing, I guess, here to note would be whatever data that you're accessing, the data would be roll up pre-aggregated from the hourly average. And so if you're accessing days data, the expected count would be 24 hours per day. So the hourly average of 24 hours. And then the observed count would be what we actually see. So the percent coverage would be 19 over 24, which is 75%. So you can get that. It's available in every measurement um, object you can get from the measurement resource by using the list method. This is just, a quiz that you can work on at home. This is also another quiz that, touch upon rollup in data. This is not super important, but I guess if you want a distinction between using data alone and using a data with rollup, that would be if you only use data like up here, you are getting data for days already pre-aggregated from hourly average. But if you use rollup, it would mean you're using base calculation of days and roll it up monthly. Um, and this is like computed on the fly, so it's going to be a lot slower. So please only use rollup when you really need it. And this is me trying to answer question one, which is to compute annual average of PM 2.5 locations at every a concentration at every single location in Ghana with any data at all. And this is me filtering out here, only taking the measurements with the coverage of 75% or over. But it's a little bit hard to look at these charts and compare them. So what I did is I make a visualization for it. So dark red would be 75% and above. Light red would be just 75, and as you can see, most of the data, you can arguably say that it's the same thing, but there are certainly some biases here that you could see. They are pretty non-deterministic in terms of like the direction of the bias, but there's something for sure at some location. So that's one of the way that you can make use of the coverage. Um, Attribute within each of the measurement objects as well. And last but not least, this is really simple. It's just, bringing everything together now that we've got the building blocks with a data frame or a table that we've already created after getting data from the API. So compare PM 2.5 daily average for the whole year at any location against WHO recommendation. So an air, pollution question right here. And per WHO recommendation, 24-hour average exposure should not exceed 50 milligram per cubic meter for more than 3 to 4 days per year. So what I'm going to do is I'm just going to pick a locations with over 75% coverage days or 274 days of the year. And I'm just going to review the chart that we got above for the box plot. I'm going to pick this location right here. Feel free to pick out the locations that you're, curious about. And what this does is essentially assigning labels to coverage. And I assign colors to each of the labels, and I draw the chart. So you can use Altair, you can use Plotly, you can use anything within Python that you feel like using. And then this would be what you get. Red stands for a day being over WHO daily average concentration recommendation. So this one, 83% coverage with an average PM 2.5 concentration of 35.3 and recommendation is 15. Green means it is within the recommendation level. Gray means coverage is not sufficient enough for us in order to like be able to evaluate whether or not it meets the recommendation. And white just means there's no data available for this day. So this year, February, you don't have, 29, 30th, or 31st. Same for these months where you don't get the last day of the month. And now that I'm done with the tutorials, if I don't want anything else to do with the API, I just run this, and this means I'm already close to connection. So right here, if I want to run a locations again, and still get 42 again, you're not able to run it because I already closed the connection. So this should always be the last step that you take for every single workflow that you have, be it in a notebook or a Python program. So that's it. I'm cutting really close. So happy to stay over for a little bit. If you have any questions or, you know, you can join our Slack channel. And I've included also the links to the documentation for you to work with the SDK easier. There's also that link to the Explorer there. But yeah, if you have any follow-up questions or anything you would like to suggest to make this better, just let me know and join our Slack channel. And that's it. Thank you.
Thanks, Min. Any
Yeah.
questions from our audience?
Mm. Thank you.
Of
Can
course.
you fetch 5 years data and then export in a CSV?
Yes. So as you can see up here, I already created, a data frame of this right here, right? So these are just summary statistics. If you want to do, like raw measurements or hourly data, you would do the same thing. But instead of, calling for extracting summary statistics like I did here, you just extract the average hourly value. And what you do to like export it would be because you already have this table in Python, you would be doing something like with pandas, you can do it with, other tools. But for example, if I want to export this to CSV, what I can do is do PD, okay, this to CSV, and then data.csv. So essentially export this table for me to a CSV file and name it data.csv. And then I run it, and that's done. Now I can go back to my terminal right here. Sorry, it looks a little bit scary. Let's see. CD. Okay, Python tutorials. See, we already, if you can, okay, let me just open it up a little bit. There's already a data.csv, which is what I just exported. So we can look at that CSV file, and it's essentially the same table that we saw before from the notebook, right? So the workflow would essentially be you make a call to the API, you choose which column or which data that you want to output to a CSV, or you can just output everything, right? And then after that, you put all of those data that you got from the API into a data frame, and you export that data frame to a CSV format using to CSV if you're using pandas or other things if you use other tools for data manipulation and export. Does that make sense?
I think it's okay.
Okay.
Min, I guess in relation to that, what does the download button kind of on the right there do? Does it download
Oh, you can do that too. You can also
Okay.
use, yeah, you can also, like download directly from the notebook this way. But this is okay, so this is using MoLab, right? And MoLab is really modern and it gives you the option to click and download. But for other, notebook tools or, within Python, there's no button to click. You have to write code for it, which is, like this way. But here, if you want to do, like a MoLab and then get the data, you can also do download CSV right here, uh, with a notebook. Yeah, good catch, Colleen. Thank you.
And one other thing is about the reset and then the page limit. You
Yes.
said you can also adjust it. Is it that we can adjust it here, or you are the one that can do that for us?
Yes. Oh, are you talking about rate limitings?
Yes, page limit and the reset.
Oh, okay. So two separate things here. Rate limiting will have to be the one doing that for you. The rate limiting refers to 60 per minute, but the page limits, you can do that on your own by updating the limit argument. So I'm going to show it to you right here, right here. So this is me, because by default, this would only return, this is not necessary because only 11 locations are returned. But for example, if you're doing like a measurements, a search for measurements, it would only return 100 by default. But if you include, an argument of limit, and then you do 1,000, which is, like the maximum number that you can do, you can adjust, like the number of results that you will see per page with the limit argument here. And there's also information about that, here, page number one limit right here. And there's this description, the number of results returned per page defaults to 100. And you can change it, but it must be between 1 and 1,000. Does that help, Clement?
Yeah.
Thank you.
Yeah, I guess also to clarify, rate limit would be more on your querying to us. That's why we limit it. But the page limit would be more the display on your end of what's been
Yeah.
already queried. So that one you can control.
Oh, okay.
Oh, and also do note that this documentation right here is right now a work in progress. We've got most of, the resources already written out that I'm gonna push to this website very soon. I included a link to this one, but we do have, like an existing Python documentation that is not that helpful, but I just want to put it out there to give you a heads up that this is a work in progress. The link that I put here, work in progress. And so there's also, this API documentation where you go to client libraries. You can access this one right here. This is pretty old and it doesn't have a lot of materials that you can use to work with to understand the terminologies and the methods that you can use with the resources. But for, basic guide, you can sort of follow it as well. But if you are looking for, information, perhaps check out the one that has work in progress next to it. Um, or let us know if you have questions whatsoever. But we're definitely gonna release that and have it in a form that you can refer back to 100% pretty soon. But so just a heads up.
Great. Thank you so much, Min.
Yeah.
And thank you, Clement and Benjamin and team that we can't see in camera for joining us today. Um, and yeah, just let us know if you have any questions. And do try out the notebook, the tutorial notebook. Let us know if you have any questions or anything that we can improve. And yeah, thank you so much.
All right.
Okay.
Thank you. Thank you. Thank you very
Thank
much.
you.
Thank you. Bye.
Bye-bye.